right, so we'll go ahead and get into this next section of notes for this unit here. This is going to be 9.3, and we're talking about special right triangles. Okay, special right triangles. So we're continuing in this unit with trigonometry and talking about all these different things that we know with triangles, and this is one of the main pieces that we want to hit on for this unit. So date that we're doing this is the 30th, and objective is we want to be able to use these properties of special right triangles to find different side lengths here. So hopefully you're able to do the lab if you were in class. If you're not in class, I'll post the kind of discovery activity on the class website as well. But essentially what we did is we basically examined these special right triangles and tried to figure out the theorems and the equations on our own first, and then we'll kind of rehash them out in the notes here. So if you've not done that, I would recommend doing that first, but in any case, we'll go through these theorems here. So first off, the first theorem we need to talk about is the 45-45-90 theorem. And it says this. It says in a 45-45-90 triangle, this is the first special right triangle that we have. In one of these triangles, the side lengths will always be A, and A times the square root of 2. Okay, so obviously we'll draw a picture with this and kind of explain what this means. And usually, if I taught this a different way, usually I'd use x here instead of a. But since we've already talked about a with the Pythagorean theorem and a representing the shortest leg, it's just easier to put it in these terms here. So what does this mean? For an example here, I'm going to go ahead and draw this triangle. And remember, it's 45-45-90, so I know one of them is 90, or one of them is a right angle. And then the remaining two are both 45. If this is the case, we talked about the fact that the shortest leg is always going to be represented by A in a right triangle. But the good news here is that since both of the remaining angles are 45 degrees, both of the legs that make up this right angle are going to be the same length. So really I could choose any variable here, but we'll just use A here. Both those side lengths are going to be the same. And that makes sense because that's one of the things that we talked about way back in Unit 5 with triangles. We said if two angles are congruent, then the sides opposite of them are also going to be congruent as well. Okay? And then this last side length here, the hypotenuse, is always going to be A times the square root of 2. And it obviously doesn't make sense just by looking at it, or how did we know that? Where did we get that from? That's where the lab came in, or that's where the discovery piece came in here. Okay, but this is the picture that I need to be able to use. Okay, so now that we have this in mind, we'll go ahead and use that theorem to find these different side lengths here. So if you need to, you can take a second, pause your video, and sketch these triangles here. But I have this first one, and it says I'm trying to find x here. So I have a side length of 6 already, and then a side length of x. If I need to, I can go ahead and label these side lengths as well. So this is one of my legs, so this will be A. The other one will be A as well. And then x is going to be the hypotenuse, so that's always going to be A square root of 2. Okay? And so if we're just using this here, we're just going to say x equals A square root of 2. And like I said, we already just labeled A, that's just 6. So I'm going to say x equals 6 square root of 2. And this would be my final answer here. There's no other way to simplify the radical at all. There's no way to change this. This is just going to be the final answer. So I just need to be able to use that theorem here to find those different side lengths. Okay? Same idea here as well. If we're looking at this triangle, we're told some of the sides, or we're told some of the legs. Both of these legs are going to be A. They're both 9 square root of 2. And then this last one here, x, again, is the hypotenuse, and we know that's A square root of 2. So just like before, I'm just going to write out x equals A square root of 2. And then if I want to plug that in here, remember we already said A is 9 square root of 2. So I'm going to plug this in, 9 square root of 2. I'm going to put it in parentheses just so you know what I'm plugging in. And then remember, we also have another square root of 2 on the side because we're using that theorem that we just wrote down. So right here we have 9 times the square root of 2 times the square root of 2. And remember, this is actually one of the tricks that we talked about when we were going through simplifying radicals. We said anytime I multiply a radical times itself, I can just get rid of the square root signs essentially, and it just becomes whatever number that is. So for instance, square root of 2 times square root of 2 is just 2. So x just equals 9 times 2, so x equals 18 here. Okay, and this will be my final answer. So using some of those ideas that we talked about with simplifying radicals, and we'll see a few of those later on as well. But this is the basic idea if I'm looking at a 45, 45, 90 triangle. The legs are always going to be the same, and then the hypotenuse is just going to be one of the legs times the square root of 2. Okay, so another special right triangle that we have here as well, another one that we went into with the lab, is a 30, 60, 90 triangle. Okay, so the 30, 60, 90 theorem says this. It says if a triangle has angle measures 30, 60, and 90, then what I can say here is I can say then it will have side lengths, and these are a little bit different. First one's still going to be A. We're writing all of these in terms of A, or in terms of the shortest leg. The next one is going to be A times the square root of 3. And the last one, the largest one, the hypotenuse, is always going to be 2A. And I'm going to put at the end here, I'm going to put respectively. Okay, so going in order from the angle across from 30 to the angle across from 60 to the angle across from 90, it would be A square root of 3, and 2A. Again, it helps to just see this in a picture here. So we'll go ahead and draw this. Of course, it doesn't have to be to scale. But here, let's say we have this. Let's say this is our 30-degree angle, and this is our 60-degree angle. And it's saying if I see a picture like this, first off, we can start with the shortest leg. We know that's always going to be the same. That's just A. And I know this is short. This is the shortest leg because it's across from the smallest angle. And that was another property that we talked about in triangles way back in Unit 5. Okay, so this would be A, which means the longest leg is going to be A square root of 3, okay, using what we just wrote down. And then the hypotenuse of these kinds of triangles is always going to be 2 times A. And again, we did this lab to kind of prove why these are these variables or these expressions here. Okay, but this is the picture that we need to keep in mind. Okay, so now we have this here. Again, can we use this to find some different side lengths? Okay. So let's look at this first one here. We have this triangle on the left. I'm actually going to move this over a little bit. Okay, we have this here. We're told that this is a 30, 60, 90 because I have one of the angles is 90, one of the angles is 60, which means the remaining one would have to be 30 here. Whoa, and that's going off a little to the side. I don't know. Yeah, I think that's just going to... Here, I think moving the picture changed things up, so give me 1 second to change this here a little bit. I'm actually going to try to erase this. All right, give me 1 sec to fix this, and then I'll get back into this. Okay, there we go. That should look a little better. Okay, so we have 30 degrees here. We know this is 30, 60, 90. In this case, we're given the hypotenuse. So like I said, if I were to go and work on this problem, I would just start by labeling all your side lengths here. And I would start with A, because everything we're talking about is going to be in terms of A. So the shortest leg here would be X, so I'll label that A. Y here is going to be the longest leg, and we said that's going to be A times the square root of 3. And then last one here, okay, the hypotenuse is always going to be 2A. So I would always start off with this. And if we need to start with A, B, and C, we can do that first. But then make sure that you know to label them in terms of A. And now that I have this, I can go and set up my problem here. So if I'm going to start with X, we know X equals A. So if I'm looking at how I can figure that out, I see that I have 2A up here and I have 10. So I can just say 2A equals 10, and then I want to divide by 2. So divide by 2 here, and I get A equals 10 divided by 2, or 5. So A equals 5, or in other words, X equals 5. On these problems, if you're given A, if you're given the length of the shortest leg to start, then it becomes really easy, because you just need to multiply it by 2 and multiply it by the square root of 3 to get the remaining side lengths. If you're not given A, I would always start with solving for that first, because then we can use that to cover all the other ones. Because now if I look at y just equals A times the square root of 3, and since we've solved for A, we can just plug that in, so y just equals 5 times the square root of 3. So like I said, we're focusing everything around the A. We're focusing everything around the length of the shortest leg. So if we can find that, then everything else just kind of flows from that a little bit easier. Okay, so next one here, using that same idea, I have this triangle here. Again, I know it's a 30, 60, 90. And just like before, I'm going to go ahead and label these here. So the shortest leg would be across from 30. So that's going to be A. That's the one that we're going to want to solve for first. Next one here is the longest leg. So this is A squared root of 3. And then the hypotenuse is always 2A. Okay, so just like before, we're going to solve for x first. So if we're solving for x or we're solving for a, I see that I have 15 and I have a squared root of 3. So I'm going to go ahead and set those two equal to each other because I know that those are supposed to be the same thing. 15 times the square root of 3. If I want to solve for this here, I need to get a by itself, and I see right now it has a square root of 3 next to it. So to get rid of that, since it's multiplication, I'm going to do the opposite. I'm going to divide both sides by the square root of 3. So I divide over here, these cancel each other out, leaving me with a, and I'm actually going to move this over to the other side. A over here. And then on the other side, I have 15 over the square root of 3. Okay, this is not the same thing as 15 divided by 3, so make sure you don't do that. And then remember, this is one of the other topics that we discussed when we were going through simplifying radicals. We said we can never have a radical in the denominator of a fraction. So we had a trick to get rid of that. The trick is to multiply the top and the bottom by that same radical here. So I'm going to say radical 3 on top and radical 3 on the bottom. So that when I do that here, I have a equals, on the top I have 15 in the square root of 3. One of those is a number, one of those is a radical, so I can't combine them, so I'm just going to leave it as 15 root 3. And then over, on the bottom, we talked about this trick before, the square root of 3 times the square root of 3 is just going to be 3. Okay? And now this is helpful because I have this fraction and I can actually simplify this just a little bit more. Because if I just take away the square root and I just look at the two numbers here, I have 15 over 3. That's going to simplify down to 5. So this is 5, and then square root of 3 would be tacked on the end here. So a here, or in other words, x, is going to equal 5 square root of 3. So always solve for a first, 5 square root of 3. And now that we have a here, we can also solve for y. We said y is just going to be 2a. So y equals 2 times 5 square root of 3. And just like before, we talked about how to do this. You just multiply the numbers, or multiply what we call the coefficients. And so that would just be 2 times 5, which is 10. And then square root of 3 is not going to change. Okay, it's just going to be double the length of whatever a was. Okay, so these are the problems that I need to know how to do. I need to be able to use these labels that we can put a square root of 3, and 2a to find what these are. Always start with trying to solve for a first, though, because that's the main piece. Okay, one last example here to practice this a little bit. Okay, let's try to mix it up and confuse you guys a little bit here. Let's say I have two different triangles, or maybe even 3 right triangles all in one picture kind of overlapping, and I still want to have the same goal. I want to solve for x and y here. Okay, well, just like before, we need to label our side lengths. So if I'm going to solve for x, let's say to start, I see x is in technically 2 right triangles here. Okay, this would be 45, this would be 45, and this would be 45 as well. So I see a bunch of 45, 45, 90 triangles in this. So if I'm starting with x, there's a couple different ways I could do this here. But let's just take this one. Let's look at this right triangle on the left side. Okay, so I have 6 as my hypotenuse here. That would be a square root of 2, right? Because we said the hypotenuse in a 45, 45, 90 triangle is always going to be a square root of 2. And then that means the remaining legs, the 2 legs, are just going to be a and a. Okay, so if I want to solve for x here, I really need to solve for a. So all I'm going to do is I'm going to say 6 equals a times the square root of 2. 6 equals a times the square root of 2. Okay, and now that I have this set up, we're going to do the same thing as before. We need to solve for a. So I'm going to divide by the square root of 2 on both sides so that I can cancel these out and that a is by itself. And on the other side here, I would have 6 over the square root of 2. And we just did a problem that worked with this here. We need to get rid of that radical on the bottom. So our trick is to multiply the top and bottom by the same radical. When I do that on the top, I have 6 in the root 2. Those cannot be combined, so I'm just going to put them right next to each other. And then on the bottom, we have square root of 2 times square root of 2. That is just 2. And then make sure you don't stop here. There is one last step. I can simplify the fraction. 6 over 2 can be simplified. 6 divided by 2 is just 3. So this is 3 square root of 2, or in other words, I'll write this up top, x in this problem, try to block out the last problem here. Okay, x in this problem equals 3 square root of 2. Okay, so with all this writing in here, I'll go ahead and label this. This side length is 3 square root of 2. Okay. All right, and then there's a few different ways to get the second one here. I'll go ahead and erase some of my markings here because we want to find y. We want to find this side length here. And like I said, there's multiple ways to do this. One of the ways that we can do this is we see that y is actually the hypotenuse of this large right triangle here. And we can see that this is a 45, 45, 90 triangle as well. This would be A now. This would be the leg of the large triangle. This would also be another leg, and then y would just be a square root of 2 like we've talked about, since y is the hypotenuse. So if I want to set this up here, y equals a square root of 2. And we already just found a. We just found a was 3 square root of 2, right? Or I'm sorry, in this case, excuse me, in our new one, a is now 6, because this would be one of the legs. So I just need to plug that in here. So y equals 6 square root of 2. Okay, so being able to use multiple right triangles in that problem to be able to solve for that here. Okay, so that is all the notes that we have for today. It's not, it's about decent size. Rest of time, you have an assignment to work on, 9.3, special right triangles. And as always, if you guys have any questions, feel free to let me know. All right, thanks guys.